This next lesson is focusing on everything we've learned so far about fractions, so we're going to be reviewing equivalent fractions, simplifying fractions, and common denominators. Let's go ahead and take a look at our first slide. So for this area, I want you to determine, are these fractions equivalent or not? That's all we need to do. Are they equivalent or not? One of the ways we figured out if two fractions were equivalent or not was to seeing if we could multiply something times the numerator and denominator to get that other fraction. Go ahead and do that now. Identify, are these fractions equivalent or not? For fraction number 1, let's go ahead and take a look. How would we go from 2 to 6? To do that, we'd multiply times 3, and so we'd have to do the same thing to our denominator. One of the ways that I check to make sure our fractions are equivalent or not is when I multiply, I'll put a little check mark next to it if it works out. So 2 times 3 does give me 6, and 5 times 3 does give me 15. So if I see 2 check marks, then I know that these fractions are equivalent. Question number 2. I'm going to do the same thing here. I have to see, well, if I'm going from 1 to 2, what am I doing? I'm multiplying times 2. So I have to do the same thing to my denominator. 1 times 2 gives me 2, and 4 times 2 does give me 8, so these two fractions are equivalent. The next one, we're going to do the same thing. We need to check through multiplication. So 2 times what gives me 6? That would be 3, so I'm going to check with my denominator as well. 2 times 3 gives me 6, and 3 times 3 does give me 9, so these fractions are equivalent as well. And then the last one. Can I go from 4 to 6? I cannot. Can I go from 8 to 12? I cannot. However, does that mean that these fractions are not equivalent? No, it doesn't. Let's go ahead and take a look at these fractions. 4/8. What is that equivalent to? In simplest form. When you see 4/8, what does that mean to you? That's equal to a half. How about 6/12? 6 is half of 12, so that's also equal to a half. Because both of these fractions simplify to a half or are equivalent with 1/2, these fractions are also equivalent with each other. So all of these fractions end up being equivalent to the other fraction that we see them next to. When you see something like in number 4, make sure you check to see if they simplify to the same fraction, because if they simplify to the same fraction, then they are in fact equivalent. So just do a double check if two fractions are not equivalent to each other when you do your multiplication check. All right, for this next section, I would like for you to create two equivalent fractions for each of these fractions. So 3/4 is what you're going to start with. Find two equivalent fractions for 3/4. When we're finding fractions that are equivalent to a fraction that we're given, we're going to multiply our numerator and our denominator by the same value, or we can divide our numerator and our denominator by the same value. Because 3/4 is already in simplest form, we do have to do some multiplication. So I'm going to, real quick and easy, multiply times 2, and that's going to give me 6/8. And then I'm going to have 3/4 again, and this time maybe I'm going to multiply times 5. You could multiply times 3. You could have a variety of answers. But those are just two examples of fractions that are equivalent. Our next one is 4/12. Go ahead and find two fractions that are equivalent to 4/12. 4/12 is not in the simplest form, so maybe I divide for this one and then maybe I do some multiplication. Or for 4/12, I know that 4 and 12 both have the number 4 in common, so I'm going to divide by 4. And that's going to give me 1/3 as an equivalent fraction to 4/12. I could have also done a little bit of simplification, not getting it simplified all the way, but I could have divided by 2. If I divided by 2, I would have gotten 2/6, which is also equivalent to 4/12. It depends on what you did. Maybe you divided, maybe you multiplied. Our next one has 1/3. 1/3 is already in simplest form, so I'm going to need to do some multiplication. Maybe I multiply times 10. Some of you like to do this because that means all you have to do is add a 0 to your numerator and denominator. That would work. And then I'd have 1/3 again, and this time maybe I multiply times 4. Again, it doesn't matter what you multiply times, but just find something easy and simple to multiply times. Don't make your life too complicated and try and multiply times something like 36. That's going to take you a little bit longer, and you have more of a possibility of making a mistake that way. And our last one, 6/8. Go ahead and find two equivalent fractions for 6/8. 4 6/8, it is not in the simplest form. Both of these numbers are even, so I'm going to divide by 2 because they are even, and I can do that. They have 2 as a common factor, and when I divide by 2, I get 3/4. 3/4 is in the simplest form. Maybe I go here and I get 6/8 again, and this time maybe I multiply times 2. And when I do that, 6 times 2 is 12, and 8 times 2 is 16. So here are my equivalent fractions for 6/8. And then here are my equivalent fractions for 4/12. And then I have my equivalent fractions for 1/3. And then I also have my equivalent fractions for 3/4. Notice that a lot of these fractions are also equivalent to each other. So 1/3 here and 4/12 here are equivalent to each other, and then it just so happens that 6/8 and 3/4 are also equivalent. Pretty cool. All right, let's talk about simplifying fractions. When we simplify fractions, we simplify through division. We divide by factors that both numbers have in common. If both numbers are even, you can always divide by 2. That's a useful hint. Now this bottom section is important. It's going to tell you when you will know if your fraction is in simplest form or not. The first rule always holds true. When the only common factor is 1, then your fraction is in simplest form. However, sometimes we forget about our factoring. So the other 3 hints here, these can help if we forget about how to factor numbers. If the denominator of one of the fraction that you're trying to simplify is a prime number, then your fraction is in simplest form. If your fraction has a 1 in the numerator, then your fraction is in simplest form. And if the numerator and denominator are sequential numbers, then your fraction is in simplest form. Some of these fractions would look something like this. 2/11 is in the simplest form because our denominator of 11 is prime here, so 2/11 would be simplest form. For 1 in the numerator, we might see something like this, 1/4. 1/4 is in the simplest form. It has a 1 in the numerator. And then for sequential numbers, those are numbers that come 1, then the next number. So something like 3/4 is in the simplest form. Maybe for a sequential number, you would even see something like 8/9. These are in the simplest form. The only factor that they have in common is the factor of 1. Let's go ahead and simplify some fractions. So here we have some fractions that are not in the simplest form, and I would like for you to simplify them for me. So starting off with 8/12, find the simplest form for 8/12. Both 8 and 12 are even numbers, so we might divide them by 2. If we didn't see that they had something else in common, we would end up with 4/6. Now both 4 and 6 are both even numbers again, so we know that they also have 2 in common. So we have to do some more simplification. We can't just stop. We really have to look at our fraction and see if they have anything else in common. When I divide by 2, I get 2/3. Now notice with 2/3 that our numbers are sequential, so I go 2, 3 when I count. When I see those sequential numbers, I know that that is the simplest form. If I had 8/12, maybe I saw that they had 4 in common. I could have automatically started by dividing by 4, and I would get 2/3 right away. I wouldn't have to take 2 steps to solve that problem. All right, take a look at 9/15. Go ahead and simplify that fraction. 9/15. 9 and 15 are not even. Neither of these are prime numbers. What they do have in common is the factor of 3. So I would divide by 3, and I get 3/5. Now notice with 3/5 that 5 is a prime number, which tells me that this fraction is in simplest form. I'm all done with that one. The last one I want you to do is 20/100. Now one thing I can notice right away is that 20 and 100 both have zeros at the end of those numbers, so they're both going to have 10 in common. So maybe I divide by 10. When I divide by 10, all I have to do is take away a 0. So I would end up with 2/10. That's a way to get my fraction looking a lot smaller. And then both 2 and 10 are both even numbers, so I can divide by 2 again, and I end up with 1/5. Notice how there's a 1 in the numerator and 5 is prime, so that fraction is all done being simplified. If I had 21/100ths, I could have also identified that they have 20 as a common factor, and I could have divided by 20, and if I did this, I would have ended up with 1/5 as well, which is in the simplest form. That's simplifying fractions. The next thing we looked at was common denominators. So we have a few steps that we followed when we were finding our common denominators. The first step was to list the multiples of our denominator. The second thing was to circle the common multiple, and this becomes our common denominator. Then we're going to rewrite our fractions as pairs of fractions with that new common denominator, and we're going to use equivalent fractions to help us with that. That's a lot going on, but as you know, these 3 steps are not that hard as long as we work at them and follow the steps very well. So starting off with listing the multiples, we'd have 4, 8, 12, 16, and then for 8 we have 8, 16. I automatically see that they have 8 in common, so that's going to be their new common denominator, so I've circled that. And then all I have to do is rewrite these fractions as a pair of fractions with common denominators. So I'm going to start with 1/4. I'm going to have my 1/4 equals something over 8. And then if you look at 3/8, it already has the 8 in the denominator. So 3/8 is done. I don't have to change this fraction. I don't have to go to 16 and change it to 16 as a common denominator. It has 8 as a common multiple. So all I have to do is change one fraction. In order to do this, I'm going to multiply the numerator and denominator times 2, and I get 2/8. So those become my pair of fractions with common denominators. I'd like you to go ahead and do the same thing for these next 2 problems here. So we have 2/5 and 1/10. Go ahead and find their common denominator, and then write them as a pair of fractions with new common denominator. And do the same for 2/3 and 3/5. Those are 2 separate problems. Alright, so I found that for my first set of fractions that they have 10 in common. And then I noticed that, well, one of my fractions already has a 10 in my denominator, so this fraction 1/10 is already all set and ready to go. The only thing that I need to change is my other fraction. And in order to do that, all I have to do is multiply times 2. So I end up with 4/10, and there is my pair of fractions. Go ahead and do 2/3 and 3/5 if you have not already. Now I notice after I listed my multiples that these have 15 in common, so 15 is going to become my common denominator. My next step is now to rewrite these fractions so that they both have 15 in their denominator by using equivalent fractions to help me. So I see that for my first fraction I'd be multiplying 3 times something to get 15, and that becomes 3 times 5. When I do the same thing to my numerator, I get 10/15. On the next side I have to multiply this times 3. Oops. And I need to multiply my numerator times 3, so I get 9/15, and there are my pair of fractions with my common denominators. The last thing we're going to look at real quickly are 2 word problems that I'd like for you to solve. Take a look at the first one. Raphael will divide his garden into equal parts. He will plant tomatoes in 6/18 of the garden. What are the fewest number of parts that Raphael can divide his garden into? Let me ask you this question first. What does the number of parts represent? What am I talking about? The fewest number of parts that Raphael can divide his garden into. When I want to find the fewest number of parts, I'm not talking about the fewest number of parts of tomatoes, I'm talking about the whole garden. So in this case, I need to know the fewest number of parts of my denominator. So if I have 6/18, how can I make my 18 as small as it will go? What am I going to do with this problem? For this problem, I'm going to simplify my fraction as small as it will go. So go ahead and simplify your fraction to find the fewest number of parts that Raphael can divide his garden into. When we simplify fractions, we divide. Now, you might have seen lots of different connections with these numbers. Maybe the first thing you saw is both of these numbers are even, so I'm going to divide by 2. That's a totally good place for you to start. If you divided by 2, you would have ended up with 3/9. I hope you didn't stop there, because both 3 and 9 have 3 in common, so you could have divided by 3 again, and you would have ended up with 1/3. If you looked at 6/18 again, maybe you noticed that both of them have 6 in common, so maybe you divided by 6. If you did that, you would have ended up with 1/3 right away. Or maybe if you looked at 6/18, you would have seen that they both have 3 in common. So maybe you divide by 3. If you divided by 3, you would have been left with 2/6, and you would have realized that both of these are even, so you divided by 2 again to be left with 1/3. Regardless of how you simplified, you should have been left with 1/3 as your final simplified fraction. Now our question's asking us what is the fewest number of parts that Raphael can divide his garden into. So we're specifically looking for our denominator. So the fewest number of parts that Raphael can divide his garden into would be 3. Notice how our question didn't ask for the fewest number of tomato plants that he will plant. It's asking for those parts, which is referring to our denominator. On our last problem, Bella was making bracelets. Each bracelet had 6 beads. 4/6 of the beads were red. How many red beads would she use in 4 bracelets? Go ahead and solve this problem. How many red beads would she use in 4 bracelets? Well, in 1 bracelet, she's using 6 beads, and 4/6 of those beads are red. So I have 4/6, and that is equivalent to 1 bracelet. For 2 bracelets, I would multiply the numerator and denominator times 2, so she'd be using 8 red beads for 16 total beads on her bracelet. And then 3 and then 4, I can follow my pattern, or I can identify that there is a pattern, and so the only thing I need to do is then multiply times 4. When I multiply these two things times 4, I'd end up with 16/24. And I need to specifically focus on how many red beads she would use. That would be 16. All right, that's our lesson for today. That's our review. See you tomorrow when we talk about comparing fractions.